Hello, everyone. Welcome to day 5, track 1 of App Dev at the Python Web Conference. I'm super excited to be here with my speaker. Wait, that's me. I am the speaker today for this session on the track. I'm looking forward to sharing with you some interesting tidbits about hacking Django channels for fun and profit. Let's get started here. I'm going to share my screen. Perfect. Welcome again. My name is Calvin Hendryx-Parker, and I am the co-founder and CTO of 6 Feet Up. We are a Python cloud and cloud consulting company based in Indiana, but we have a global footprint with folks all over many time zones. And so I'm super excited to be speaking at my own conference about some cool stuff that we're super passionate about. What's really neat is that what I'm going to show you today during this talk, like I did in my talk yesterday, was I'm going to be talking about Loudswarm, the platform we're using. So I love being a little meta about the whole situation, that I'll be talking about something that I'll be showing in the platform that I'm showing it on. So hacking Django channels for fun and profit. We're going to kick it off with a little bit of a backstory. For those of you who don't know, we kind of had a nice little Python 1994 history retrospective as our opening keynote today. But Django started life as a synchronous web server in the year 2005. Well, 2005, the web is synchronous at this point. I mean, the web is still mostly synchronous up until probably a few years ago. We really haven't hit the stride for WebSockets. Maybe we had long polling. We had some CGI tricks to push some things into the page, but there really wasn't a two-way web back in 2005 when Django started. But our platform is based on Django. So we're going to talk about the fact that asynchronous is becoming more a part of Django, especially with each 3.x release. Prior to the 3 series of Django, there was really not an asynchronous story. There was a channels add-on for Django, but you had to install that, add it in, and it really wasn't like a kind of fully integrated, fully baked portion of it until Django release 3.0. And now we had a asynchronous router and the ability to serve asynchronous applications side by side with Django. But what does Django actually look like? So we need to know a little bit about how Django technically processes requests to talk about the asynchronous versus synchronous nature of it. So what I've got on the screen is how a Django request looks like. So HTTP requests come in from your browser. They go through the middleware to your view function that's been defined in your Django application. That view function does some work on the back end, calls into the ORM, pulls out your models, does some work there, and then it goes back through the middleware again as a response. It's a very stateless, typical HTTP way of actually doing web requests. And this is all done synchronously. Since we're living in the WSGI world, the WSGI is the web service gateway interface, was kind of the follow-on to CGI as a way to make sure it was kind of a standard way to pass requests in and out of Python applications that are being served on the web. So I talked about WSGI, and the next thing we're going to talk about to start making this into an asynchronous talk is going to be talking about ASGI, so the asynchronous server gateway interface. Let's make this work bi-directional. And what was nice is that in Django 3.0, starting with Django 3.0, it was actually very easy to switch this from being the WSGI world of synchronous requests with a specific interface for doing that to the asynchronous requests way of doing this. You just swap your WSGI.py file for the ASGI.py file, and that now will become your entry point into your application. I mean, this whole bit here could be an absolute talk on its own. And actually, I've linked here to kind of a really good, detailed, in-depth talk about the changes in Django 3.0 that came with moving to ASGI as opposed to WSGI. But prior to Django 3, channels provided the async support and ASGI support for allowing long-running connections and doing things such as WebSockets and MQTT and all these fun bits. Oh boy, then we're talking about how we pronounce it. I will go with WSGI, ASGI. Sometimes I'll say WSGI and ASGI. I will use them interchangeably, not the 2 terms, but the 2 pronunciations for each of said terms. So to get this all kicked off, though, I think I really need to dive just a next layer lower and show everyone what a WebSocket actually is. So talking about, why do we want to do ASGI or ASGI and async inside of our Django application? Because we actually want to be able to use some more higher level interactivity and engagement in our applications. If I actually switch back over here to my demo, we'll show off. This is the LoudSwarm site as you see it today. You can, well, let me push this down a little bit. The LoudSwarm Slack box, you can see it right here. I'm sure some folks will have some fun posting some messages into Slack. That is powered by a WebSocket connection to the LoudSwarm servers. So on the backside, we have got persistent connections, and the browser is establishing that persistent connection, and data can now flow both ways across that connection. And if we look at what that actually looks like, you can see here, I've got the web inspector open, and I'm looking at other types of connections. In Firefox, it actually has a specific tab for WS or WebSockets. But I can see over here, the /WS route in our application goes to the WebSockets, and you can see the messages being sent back and forth. And I can actually, yeah, so some folks are talking right now. You'll start seeing some real-time chats popping up in that stream. There we go. There's one from Daniel, and then Chrissy. And so folks are actually like talking in Slack, but that Slack is sending a webhook over to our app, and then our app is using the real-time connection to push the messages into our browser in real time, which is pretty darn cool. So to be able to accomplish that, though, you have to have some kind of an asynchronous, loop or some means of processing that and maintaining that long-running connection to be able to pass messages back and forth. Channels adds this to Django. So, and Channels isn't WebSocket specific, but it enables us to use the WebSocket protocol. But right now, what it does, so as of Django 3.1, it wraps asynchronous views that have been added in 3.1, and 3.0 really only added the asynchronous router. Channels was still doing the old thing and really only did WebSockets. As of Django 3.1, really have kind of opened up the doors for doing more things with an fully asynchronous event loop. So what is channels? Channels, you can think of it in kind of three major components that make up the channels add-on or framework for Django. It includes consumers. And this is the normal thing you're going to think about when you're developing a channels application. It is going to be basically a model, or not a model, sorry, a class you build that's going to have methods on it that get called when we send specific kinds of events across our event broker. And so those get sent across the channel layers. This is what how we talk between our code that we're writing that we want to send asynchronous messages and those consumers. And then the last bit, which actually is going to be more interesting to us later, is background workers. We can actually kick off asynchronous tasks to happen in the background, much like a task runner in Celery, only a lot more lightweight and not with some of the same safeguards that are included with a really more full-blown task runner like Celery. But you'll see in a moment actually fit really well with our use case in what we're getting ready to do next, because I've only talked about our Slack integration, but I'm going to talk about doing something more interesting with that here in a moment. So if we look at what actually makes up a consumer example, so this is what I talked about, that we're going to build a consumer that is a WebSocket consumer inside of channels. It actually it's not too hard to kind of wrap your head around it. It's got a couple methods that you'll implement as part of its contract, a connect and a disconnect. And actually, if you all wanted to open up your web inspector right now and look at the WebSocket connections and going back and forth inside of LoudSwarm, you would see that connected true. You would also see it pass across your token for your authentication. So don't paste those anywhere, because those are actually your way of authenticating into the API. It's also your way of authenticating into our WebSocket. You'll see the tokens push back and forth. And that's just because we've established how our application is going to push data one side and back the other way. It's just going to be JSON payloads that go back and forth across this persistent connection that's been opened up on either side of this. So when we see a received JSON, we can now take that and then act upon JSON coming in from our WebSocket. And when we push events out from our code, we'll typically have handlers inside of our consumer that then do some action with that code. So you can see that that's kind of the pattern we're following here for that. The conference talk about the conference platform. That's kind of what I'm specializing in this time. How do we showed a consumer, but we've not hooked it up to anything. A consumer alone doesn't do anything unless you've got something routing to it. This should be familiar to folks who are in the Django community. You typically need to set up your URLs so you can route your views or your requests coming in to the views that are on the backside and then going back out. We will do the same thing with ASGI. We will actually set up a router inside of our, basically your URLs. In our case, we have like WebSocket protocols. We can actually then now hook up our URL patterns, just like we would hook up for views inside of Django. We hook up URL patterns for our WebSockets. So /WS now will be routed to the WebSocket consumer instead of being routed into the views of our Django application. One thing to note, this specific example I'm showing on the screen is directly from LoudSwarm, but we're actually using the older channels 2 right now. We've not fully upgraded into channels 3. If you do upgrade to channels 3, you'll notice here I have a comment saying HTTP to Django views is added by default. That is not true anymore. In channels version 3, you are explicitly required to put in the HTTP protocol handler. So I like this because explicit is better than implicit. I'm a big fan of ZenPython, and I feel like adding that in channels 3 was a good move to make sure that it's explicit and not magical about how traffic gets routed from one place to the other. You'll also notice in our routing here, we've got a WebSocket protocol handler, and then you'll see a channel handler. This is where we're going to start getting into being able to do asynchronous background tasks. You can actually call to a channel instead of a WebSocket or to HTTP, and actually have that now handle your, in this case, Discord sender. So the big feature we're going to talk about is adding in these background workers so we could support persistent connections to Discord. We want to add Discord capabilities into our application, which is going to be slightly trickier than what we did for adding in the Slack integration, because Slack supports, well, the way Slack currently is supporting it is with webhooks. Now Slack is changing their tune yet again. They used to be WebSockets, they went to webhooks. I feel like they've gone back to WebSockets again. So this talk may change in a year after we've gone back and forth and now implement Slack in the same way we implement Discord. I think it's a better option to go with some kind of a persistent connection. So we will actually look forward to Slack, fully rolling out a more real-time API with WebSockets. But let's talk about these background workers. Background workers are new to channels and probably less used, but that's actually what we want for our application. We want a lightweight and easy way to spin up at start and connect into a WebSocket from our Django application, not from the browser. So this is very different. We're not talking about a browser talking to our application. We're talking about our application talking to another server, completely like computer, server to server type communication, but we're going to use WebSockets, which is a persistent connection. We're not doing stateless, REST API calls. We're really going to make sure this is real time and gets all the data going and flowing bidirectionally across that pipe. So in our case, we really want the reverse. Instead of having our browser talk to the server, we're having our server talk to another server, and we're initiating the WebSocket connection from our Django application. So a worker and channels, this is what we want to do. We're going to build our Discord integration layer so we can talk to the Discord WebSockets this way. So we connect, this is a little bit of background on the background workers. We'll connect our WebSocket with the background worker in channels and listen for messages coming from Discord. Discord will, just like you see in your Discord client, you can see someone typing, you'll get the messages in real time, you'll get all the event notifications that would come into any channel that you invite your Discord bot into. For those of you who've not done tutorials or written Discord bots, there's really some easy tutorials out there, and there's a great Python library for connecting to Discord and listening for these kinds of events. Now we use the Django channel layer because obviously we need to maintain that persistent connection. So this is an area where Celery wouldn't help us because Celery is still pretty stateless. It takes tasks off of a queue, it runs the tasks, and then they're done. They don't typically do long running tasks with that. Now with the channel workers, they are fast, easy, and lightweight, but there's a catch. They perform, at most once operation. There's no guaranteed one-time delivery. There's no real error checking going on. Kind of like UDP, you're responsible for making sure your message is either received or that you handle any kind of errors along the way as part of your application code, not as part of the framework that you're using to connect to those background tasks. So if we jump into this real world case, Discord requires me to talk to it asynchronously via a WebSocket and to receive and send events. We've been using Slack for the integration for our chat inside LoudSwarm, but we really wanted to add in Discord as an option for conferences that don't like using Slack or want to use the Discord style of messaging. Why do we want to do this inside of Django? That's the key bit here. We could have just written our own standalone, asynchronous running Python script or server on the side that could make the connection talk and then talk into the database, or message into our application, maybe simulate the webhook interface that we had with Slack. But really, we want to leverage all the nice batteries included that we get with Django. I mean, why not? We've got awesome stuff inside of Django. Let's use it. We really want to use things like the ORM to be able to receive an event over a WebSocket and then actually directly talk to our ORM and create message models or messages into our database directly. Really seems much more convenient. And obviously, it gives us less moving parts. We're not having to maintain yet an external application to talk to a WebSocket service someplace else. So what we did was we're going to hack our own worker. We want something really Channels doesn't do out of the box yet. I mentioned we've got background workers, but those background workers you can really think of just like Celery tasks. If you are familiar with Celery, inside your Django application code, you'll call, you'll decorate or call off to an asynchronous task and feed it some information, and then Celery will put it on the queue. A worker will pick up that work, do the work, and then it returns the result or whatever operation it's going to do, and then it stops. Like it is done at that point. It doesn't start on launch of Django, for example. So we have kind of a slightly different model from the typical worker. The Django channels worker works the same as like the Celery one. It expects you from your application code to make a call to the channels protocol and then call a specific route inside your channels router to do some kind of work. You think of it like, for example, doing thumbnail generation, maybe asynchronously. Potentially you want to have folks interact with maybe your photo application, they upload a photo, maybe initially the photo doesn't have thumbnails right away, and you don't want to do that in your main thread, but you want to then say spawn an external process inside of Django that handles doing thumbnail generation. It's a good example because if it fails, not a big deal. You can kind of have some periodic cleanup tasks that come by and do those other generations. It's not necessarily time dependent whether it shows up or not either. So those are good tasks for Django channel workers as opposed to maybe doing it in Celery because it's really lightweight and we want it to happen asynchronously. We'd want to be able to spawn as many channel workers and do that work on the fly. But it doesn't provide us with a means to start with a predefined set of work out of the box when we start our Django instance. And so that's what we're going to talk about. It's hacking our run worker to enable this new functionality and feature. So if we look at this is the run worker from Channels. And so we're going to make our own version of this. Actually, we've greatly simplified this code since I put this together and basically just subclassed the stateless server from Django Channels and added in the one bit we needed. And so if we kind of go from the top down here on this code, we look at the handle method, and most of this code is identical to the original implementation, except we're going to have, and our terminology here for this is lackeys. We're going to initially fill our workers with some work to do on start. So you can see as we look here, we're going to loop over the channels, looking for listeners, and then we're going to append lackeys, work to the lackeys connections to actually look for outgoing connections. So we'll configure some kind of class or work, and we'll start appending those to our lackeys, and then they'll start running asynchronously in that event loop. So why do we do this? We don't want to just respond to a channel error message to make something happen. We are turning the standard channels concepts, a bit inside out. Again, we're not calling to channels. We're letting channels start up on start and actually make a call out kind of proactively to go and do work. So let's look at our two examples. Now we can kind of look at how we implement our worker and have it start a long-running coroutine at Django start. So we're going to build a chat client in Django that's asynchronous based on the Discord, PyDiscord library. So we're actually subclassing an already asynchronous library built and maintained in the community that actually is just wonderful. I mean, if you really want to check out building a Discord bot, check out this one. There's a great examples directory in the PyDiscord package that gets you up and running really, really quickly with kind of how to about how to get a Discord bot built. So now you can go forth and build all kinds of crazy bots to annoy your children in their Discord servers, which is something I've been thinking about doing myself. But we are using it more maybe usefully inside of Loudswarm so that we can watch for chat messages just like we see in Slack and feed those onto the same page in the exact same method as we see for what we're doing inside of Loudswarm. So when a new message comes across the WebSocket, we have handlers, and those handlers basically pick up the data. We've massaged the data to kind of match the same data format we were using for Slack. So we really had minimal changes to the back end of the application. Again, we've kind of made this a little more robust. We did this as part of a ship it day here at 6 Feet Up. We have these 24-hour days of innovation parts of 6 Feet Up where we actually get to kind of hack on cool stuff and scratch cool itches. And this is one where me and another coworker said, we want to add Discord to Loudswarm. Let's see if we can do it in 24 hours. And sure enough, in 24 hours, we did it. And sure enough, in that same 24 hours, we demoed it, Chrissy was able to crash it for us. So I will thank Chrissy for well road testing some of our Discord integration, because during my demo, she put some messages in there that broke the whole thing. But we've since fixed that. But yeah, it was really interesting to be able to do that in an overnight session of just intense hacking to be able to throw a new functionality into a fairly larger platform. So that was receiving messages from Discord, and we can actually generate notifications on a scheduled Celery task. We generate, or when you're in Loudswarm and in the Slack channels, you'll see the conference bot sends into the channel periodically, like 4 or 5 minutes before the talk, like upcoming talk in the next 4 minutes. We want to simulate that same behavior in Discord, and we can do that. We can actually send to our Discord sender, and I showed that in the routing at the very beginning here. Where's the routing at? Oh, here it is. That channel right there, there's WebSocket and channel. Here's the example where we're actually using the channel protocol to send messages to Discord. So if we get back to the Discord bit, this is the implementation of Discord Sender. It is, again, an async consumer of channels, and we has a method called send to Discord. So when we call the channels protocol and the send to Discord message or method of that, it now calls and basically does the exact same thing. We can now send from, because we send it from Celery. Celery has a scheduled task that's running once a minute or every couple minutes, looking for sessions that it should be announcing. And instead of now just calling Slack's announce that we had set up inside of Celery, we can actually just send messages back across the already established WebSocket connection with Discord. So it's not stateless. We're now receiving messages and sending messages down that same exact channel. What's nice with the PyDiscord library, it also supports the ability to start sharding these channels. So as your application grows, and maybe you need to stress test this a little bit, but you can actually shard multiple workers across the Discord bots, so you can actually handle more work. Right now, we're only using a single one because it's not enough traffic to send that much load across the single WebSocket at the moment. But it does provide us a means of actually just changing a configuration in our Terraform, which I talked about yesterday, to spawn more of these Discord or these these channels workers, background workers, to handle additional load as needed. So we can actually scale up and scale down the application in the same way we would scale up and scale down the API on the front end. And so then this is an example of how we send. So we send asynchronously from our Celery tasks, because those are technically still running like Python synchronous code, but we can call into the asynchronous channel layer for channels as opposed to the channel layer for Celery. Got to keep that straight between, we've got multiple asynchronous task runners now since we're using Celery and channels for this. But we just send to the name from our router, Discord send. We send the type, which maps to the name on the consumer, which makes this really easy to work with because the names all just match up to the methods or to the routes. And then we set what channel we're sending to, because we only want to send to a specific Discord channel. We don't want to broadcast it to the whole Discord guild. I think that's their terminology. I'm whole new to the Discord world, but I'm learning quickly. And I've picked up quite quickly, and it was actually fun doing this project because I learned a lot about Discord and asynchronous operation. And then our message, and then it goes into Discord, and all is happy. Actually, I have an example. I have an example of that. So you can use this actually for any old long-running task. I mean, if anything you can think of now where you need to make a long-running connection on start of your application can now do that. And so we've kind of thought about where we would take this next, our kind of wish list for this code base. We've refined our technique for spinning up and running these long-running tasks right away. I would love to see this getting added into the channels code base. I'm going to encourage the team when we get maybe our next ship a day, or maybe an innovation afternoon, or we can do some like 10% give back time to see if we can actually pitch this as a PR or an add-on for Django if you want to be able to enable the same behavior, because I'd love to make sure that, or love to make this available to others to use as well. I would love to also put in some more examples of additional long-running tasks. So we show the one long-running task that connects to the WebSocket. There's kind of two options here, and also being able to do single-shot coroutines. Maybe on start and on stop, you would want to be able to do set up and tear down type operations for your application, but you want to be able to do them asynchronously and kind of detect startup and detect shutdown. There aren't really events like that in the Django ecosystem for doing something on start or doing something on shutdown. But with channels and these background workers, this actually can enable that kind of functionality for you if you did need to do that. Maybe you needed to notify a load balancer for adding an additional Django worker into that load balancer, and then removing it on stop. There's kind of example things you could be doing with that. Now, quick tips and tricks, because everyone needs this. One of the things we learned while doing the LoudSwarm implementation of the WebSockets front end, even not just the Discord integration, but when we did the Slack bot integration, the channel layer capacity defaults to 100. And if you push more down that channel than that 100, they will drop silently. So when we were load testing our application and sending demo messages, with 1,000 users connected, we started seeing missing messages. One thing you're going to want to do is actually you can configure the Django channel layer capacity. I forget. It's an environment variable in your environment variable. It's a setting in your Django settings file for channels that will allow you to actually, we push it to 1,000 to start with for now, and that's been sufficient for all the events we've been doing recently. But if you notice you're getting messages drop silently from channels, it's because that default layer capacity is 100. You'll probably want to bump it up. We've not noticed any major bad side effects to doing that so far. But we're also running in Fargate and giving dedicated containers to the WebSocket instances, which is nice because we can now configure those containers to have, say, more memory, maybe not as much CPU, and then they can actually handle more and more concurrent connections simultaneously. So that's one tip and trick. It's not in the docs. I don't know why. Maybe I need to go make a pull request for that too when I get a moment to breathe. But with that, I want to say thank you so much for having me here at Python Web Conference.